All right, guys, here's the final video for today. I don't want to make it too long because I want you to actually enjoy your day. Hopefully, you did your homework last night. Either way, you have all weekend to work, but just be ready on Monday. So, let's look at it. This topic is about graphing, square root, and cubic functions. So, for instance, we just did the square root of x before. So, let's say we want to graph y is equal to the cube root of x and then determine the domain and range. Okay, and we probably should have done that in the other one, but about domain and range, but it's okay. We can talk about it in class. So, when we look here, we're going to look at the graph of y is equal to the cube root of x. All right, y is equal to the cube root of x. And I'm going to pull some numbers. When you ask me why I'm pulling these numbers, it really has to do with the fact that I understand cube roots, right? So if I do y is equal to x cubed, and I just want to pull out some things, let's say I choose -2, -1, 0, 1, 2, right? Then this would be -2 cubed, which is -8. This would be -1 cubed, which is -1, 0 cubed, which is 0, 1 cubed, which is 1, and then 2 cubed, which is 8, right? So just from this alone, if I were to do a quick graph of this, it would be something like this. So -1, -1, -2, -8. Let's see. 2, 4, 6, 8. I believe this is the 8 mark. And then 1, 1, 2, 8. So that right? So this is my y equals x cubed, right? And so when you ask me why I'm going to choose the domains here, I'm going to do this one in purple, then it's because of what I know about y equals x cubed, right? Basically, these are inverses, so I can flip and say -8, -1, 0, 1, 8. And without me even putting it in and taking the cube root of -8, I know it's -2, right? The cube root of -1 is -1. The cube root of 0 is 0. The cube root of 1 is 1. And the cube root of 8 is 2. And so we're going to come here. 1, 2, 3, 4, 5, 6, 7, 8. And go up 2. And then 1, 1. 0, 0. -1, -1. And then -8. -2. And so what this will look like something like this. Notice what I told you before is true, though. If we were to fold along y equals x, we will see a reflection. And that's with any function and its inverse, right? So there we are. What's in purple is the graph of y equals the cube root of x. Okay, y equals the cube root of x. Now, there are times where we're going to be asked to graph like something more expansive, right? And it could be the square root of x, or like y equals the square root of x, or it could be y is equal to the cube root of x. But you're going to see extra things added to it. So in order to graph these things, right, in order to graph something like this or something like this, this should take you back to transformations of functions, which I know you guys know, where A affects like the vertical stretch and compression. The minus H affects the left and right part, and the plus K affects up and down. So here, A, same thing, H, same thing, K, same thing. So whenever we want to graph these, we want to start by sketching the graph of y equals a times the square root of x, or y equals a times the cube root of x. After we do that, then we're going to translate like horizontally by h units and then vertically by k units, okay? But first, let's kind of compare a bit the cube root of x function with like a being multiplied to it, right? So in this example, we already know by the previous example that if we're to do y equals the cube root of x, then we could use -8, -1, 0, 1, 8. And we would get out -2, -1, 0, 1, 2, right? So I'm going to go ahead and graph it quickly. So this would be, let's see, we said -8. 1, 2, -2. We know -1, -1, 0, 0, 1, 1, and then 8, 2. Right? So that's that. And then our graph of let's say y equals -3 times the cube root of x. That's going to be, you know, something a little different. We still have our -8, -1, 0, 1, 8. But our y is going to be, for instance, if we get out -2 here, multiply that by -3, that would be +6. And then -1 times -3 would be +3. And then 0, and then -3, and then -6. So when we graph here and come to -8, for instance, we have to go up to +6. So that's 1, 2, 3, 4, 5, 6. Right? And then we would go -1, 3, 0, 0, 1, -3, and then 8, 6. Actually, 8, -6. And there we are. Notice that there's two things that happened here. There was a reflection across the x-axis, right? And also, there's a vertical stretch by 3. Okay? There we are. These are not inverses, by the way. But we can talk about the domain and range. That does ask for us to state the domain and range. And I'm sorry I didn't do that. So when we look here, we know that the domain, right, it's an arrow, comes all the way, all the way, all the way, all the way, comes down here, it's an arrow. So the domain is all real numbers, right, here. And then the range, this comes to the y-axis, so does this one. This is all real numbers as well, right? Very good. And that's actually true for all cubic functions. It's true for all cubic functions. However, when we look at square root functions, where did we put our square root function? Like when we did this one, it's not true here for the square root of x. Notice how it starts at 0, right? And it increases. Now, when we look at our y values, right, our range would be all real numbers. But let me make sure I'm right about that. Oh, this is plus or minus. Okay, so our range will be all real numbers for plus or minus the square root of x. But when we look at our domain, it goes from 0 to infinity because we can't take the square root of a negative number. All right, I'm glad we went through that. So back to this one. This is the last example, and then we're done. Okay, so let's say in this final example that we're asked to graph y equals -2 times the square root of x plus 3 plus 2. Then state the domain and range. Okay, then state the domain and range. All right, so what we're going to do is sketch the graph of y equals -2 times the square root of x, right? And so let's talk about what that would look like. I'm going through this process for anyone that needs it. Note that we cannot take the square root of a negative number. So we would start at like 0, 1, 4, because we're thinking of like perfect squares, right? So this would be 0, 1, 2, 3. But if we tag on, that's for y equals the square root of x. So if we come over and do -2 times the square root of x, then we're going to multiply each of these results right here by -2. So that'll be 0, -2, -4, -6. Okay? So when we graph this, all right, we're going to go 0, 0, right? 1, -2. 1, let's see. That should be 4, -4. And then 9, -6. All right. And so there we have it. That's our graph. That's our graph. So next we're going to translate the graph horizontally h units and vertically k units. So what is our h? What is our k is the question, right? Notice here that our original is y equals a times the square root of x minus h, right? Plus k. So hopefully this makes sense that our h here is -3 and our k is +2. Kind of how we were doing when we did our quadratic functions, right? So again, h is -3 and our k is positive 2. So that means we're going to take each point that we've plotted for this negative 2 square root x, and we're going to translate it left 3 and up 2. All right. So this is left 3. So 1, 2, 3, up 2. So that'll be here. Left 3, 1, 2, 3, up 2. All right. And so we have something here. So this point right here, notice is negative 3, 2, right? And then, of course, we know this point here is 0, 0. And notice how they'll continue to go right and down, okay? So if we were looking at our domain and range, which it asked for, then note how our domain starts right here at negative 3, and then, and that's our, for this function, right? We note our domain starts at negative 3, and since it's going right, that's where our x values are increasing. So it's from negative 3 to positive infinity. And then for our range, right, so the domain was this part, right? It's a point, right? So let me explain that. This is a point. The graph clearly continues to go down, but also it's going right. So therefore, we can trace it all through here. And notice that there is an arrow. So we start here and continue to go right, okay? So there it is, just like that, okay? Now for our range, we still start here, but we're looking at our y. So our y here is 2, right? But it's a point, so we're not drawing an arrow, we're drawing a point since it's an endpoint. And the graph, yes, it's going right, but look, it's going down. So look at what's happening to the y values, right? So we come over here, we draw our arrow, and so it goes from 2 to negative infinity, or we like to go from least to greatest, so from negative infinity to positive 2. All right, that's it. That's how you're going to graph all cubic and other functions. Also, another way of writing this could be x is greater than or equal to negative 3, or y is less than or equal to 2. That's it.